In this video, I am going to discuss about the chemoselectivity and the introduction to the protecting groups. So before knowing what a protecting group is, let us discuss about selectivity. So we know that most of the organic molecules contain more than one functional groups. And let us see an example of paracetamol. So paracetamol is prepared from para-aminophenol by reacting it with one equivalent of acetic anhydride. So here acetic anhydride is the acetylating agent. This is the acetylating agent. And pyridine is the base, and we get the N-acetylated para-aminophenol. So that is paracetamol. So if you take excess of acetic anhydride, both the OH as well as the NH will get acetylated. So if we have N-acetyl and O-acetyl. So if we get the diacetylated product, we can use sodium hydroxide to deacetylate or the hydrolysis of the O-acetyl group to get back the paracetamol. So the functional groups they react in more than one way. So most of the functional groups they react in more than one way, and it is the role of the chemist to predict which functional group will react and where it will react and how it will react. So selectivity is which functional group will react, where it will react, and how it will react. And when we go into the types of selectivity, there are three types of selectivity. So one is regioselectivity, stereoselectivity, and chemoselectivity. So now let us look at what is regioselectivity. So regioselectivity is where it will react, that is at which position. So let us look at the addition of HCl to an alkene. So this is propene. So if we add HCl to propene, we get 2-chloropropane as the major product and 1-chloropropane as the minor product. So this addition goes via the Markovnikov's rule, where the negative part, that is Cl minus, will add on to that carbon which has got less number of hydrogens. So this is regioselectivity. So let us look at stereoselectivity. Stereoselectivity is how it will react. In other words, it is stereochemistry of the product. So let us look at the epoxidation of this alkene. This is MCPBA is an reagent to do the epoxidation. Is a reagent to do the epoxidation, and we get 95% of this diastereomer and only 5% of this diastereomer. So stereoselectivity is which stereochemistry are we going to get. So next is chemoselectivity. Chemoselectivity is the which functional group will react. So let us look at the synthesis of salmifamol. This is the sister drug of salbutamol, which is an anti-asthmatic drug. So here in this compound there are two functional groups. So one is an ester and this is a ketone. So in the final product, both the ketone is oxidized to the hydroxy and the ester is hydrolyzed to the hydroxy. So in the first case, we are using sodium borohydride as a reducing agent. So sodium borohydride will not touch the ester and it will reduce the ketone to the alcohol. So that is a chemoselective reducing agent where it will reduce only the ketone and it will not touch the ester, and we get this product. And in the next step, this is debenzylation followed by the reductive amination to get this compound, and in the final step the ester is reduced to the alcohol. So here the best reagent to reduce an ester to an alcohol is lithium aluminium hydride. So this is the chemoselectivity, that is which functional group will react. So, when we look at the reactivity of the less reactive group, so that is how to react the less reactive group. So, there are two to react the less reactive group. There are two ways. So, if you look at this compound, where we have the hydroxy, this one is a secondary hydroxy, which is more hindered and less reactive, and the other one is the more reactive primary hydroxy group. But the product which we are looking for is the acetylation of the secondary hydroxy group, that is this one, is the desired product. Acetylation at the secondary hydroxy group is the desired product. So the treatment of this hydroxy with one equivalent of the acid chloride will not work, because primary alcohol is more reactive compared to the secondary alcohol. So the one thing that can be done is we react both the hydroxy groups. So we react both of this and then do the deprotection. Okay, so here we are taking excess of acetic anhydride so that we get a diacetylated product. So that is both the secondary hydroxy as well as the primary hydroxy are acetylated to get a diacetyl product. So in the next step, we use potassium carbonate in methanol that will deprotect or hydrolyze the acetate of the primary hydroxy group. So because this is less hindered acetate, so it will get hydrolyzed, we get the free primary alcohol, and this is the in 65% yield. So that is, we react both the hydroxy groups and then unreact the primary hydroxy group. So this is the one way to do the reaction on the less reactive groups. And the second way is to protect the more reactive groups in the molecule. So how that is the reacting, that is by the protecting groups. So let us look at an example. So the more usual way of reacting a less reactive group in the presence of a more reactive one is by way of the protecting group. So let us take the example of ethyl acetoacetate, where we have two functional groups. So one is a ketone and the other one is a ester, and by the reaction of phenyl magnesium bromide, that is the Grignard's reagent, we have to get this product. But among the ketone and the ester, the more reactive functional group is the ketone and the ester is the less reactive group. So here if you react it with phenyl magnesium bromide, the ketone will react and we get this alcohol, and but the desired compound is the addition at the ester to get the alcohol. So as you would expect, simply adding phenyl magnesium bromide to ethyl acetoacetate leads mainly to addition to the electrophilic ketone and not the ester. So in order to react at this position, that is the ester, we have to protect the ketone. So one way of making it is we have to protect the ketone with a suitable protecting group. So ethylene glycol over here, so we get an acetal over here, and on reaction with the Grignard's reagent we get an alcohol, and in the last step the acetal is deprotected and we get back the ketone. So the first step puts the protecting group onto the electrophilic ketone and then react it with the Grignard's reagent, and finally the deprotection to get back the free, the ketone. So protection is one of the strategies in the organic synthesis. So it is the temporary modification of the site, that is, we are going to modify the site at which the reaction is undesirable in bi or polyfunctional molecules. So let us see the reaction of this ester with a Grignard's reagent. So this is an impossible Grignard's reagent because it will self-destruct itself, and the desired product is this one. So what we have to do in order to get this product? So the first step is before doing the Grignard's reagent, we have to protect this ketone with ethylene glycol to get the acetal. So the ketone is protected first to get the corresponding acetal, and on this acetal, if we react it with magnesium metal in presence of dry ether, we get the Grignard's reagent, and then we will react it with the ester to get back the alcohol, and the final step is the deprotection of acetal to give the ketone. So this is the strategy that is followed to get the desired product. So let us see the characteristics of protecting groups. So the protecting group should be introduced and removed under mild conditions. So the reaction should be a milder one, that is, the condition should be mild enough. And the protecting group, it should be stable to carry out the reaction at the desired site, and it may also be converted to other functional groups directly at the end of the reaction if required. And the protecting group should have minimal number of functional groups to avoid further complications, and it should be readily available, so that, or the commercially available one, it should be non-toxic and should not attack the regenerated product, and it should also be stable during chromatography, that is, while doing column. And protecting group should be achiral for achiral reactions, and they should obey the rule of orthogonal protection. So in a multifunctional substrate, each functional group is deprotected with different functional protecting groups, and the deprotection of these functional groups are done sequentially under different conditions without affecting other sites. So these are all the characteristics of the protecting groups. So in the next video, we will discuss about the protection of alcohols.